going? Number 15. All right, number 15, we're doing notes and classwork on volume. All right, tomorrow when you come in, you're going to have some classwork on volume. Some of it is going to be fill in the blank. The stuff that we're going to highlight today is probably part of your fill in the blank for tomorrow. Okay. All right, so today we are going to talk about volume of rectangular prisms. All right, I want us to talk about volume versus area because we've done a lot of area. We did like rectangles, parallelograms, we did triangles, we did trapezoids, we did those funky shapes. We did a lot of area, all right? But today we're going to mention volume, and area and volume are very, very different. So what I want you to do in your head right now, in your head, I want you to picture an empty swimming pool. Like a rectangular, empty swimming pool, not a funky shape, okay? Don't go funky on me. All right, is everyone picturing a rectangular, empty swimming pool? Got that in our head, okay. Now, when you picture a swimming pool, I want you to picture it empty for right now, okay? There's nothing in it. Now, when you're picturing the swimming pool, on the floor of the swimming pool, it has to be either painted or it has like one of those liners. I don't like the liners because they're slick and I end up falling in like 3 feet of water and think I'm drowning, okay? So, but you're picturing that swimming pool. You're probably picturing me drowning now, okay? But, all right, so we've got our swimming pool. If I was going to put that liner in the empty swimming pool or if I was going to paint it, because some swimming pools are just painted, that painting that I'm doing on the sides, on the bottom, that is area because it's flat, right? If I'm just painting it, that's flat. Y'all agree? When I put that water in the swimming pool, I can jump in that water, can't I? Swim around, move around, because it's three-dimensional. The water that's in the swimming pool, that's talking about volume, okay? So volume is 3D. So like, for example, in this room, if I was going to paint the walls, it's flat, that's going to be area. If I was going to fill up this classroom with M&Ms, that's going to be volume and a whole lot of M&Ms, okay? So, volume, three-dimensional, I can touch it, I can feel it, I can stick my hand in it. Area, all I can do is stick my hand up against it. We can't go into it. Do we agree with that? Y'all okay with that? Okay. All right, so this very first sentence on our notes for today says that the volume of a solid is the measurement of space occupied by it. So that space in the swimming pool of water, that's my volume. If you look at any of the shapes that we talked about yesterday, so any of these little shapes, all right, the space inside this paper, that's the volume. What's the paper, though? Area, very good. So the area, like that flat spot, that's area. Inside it, like if I was going to open this up, see I got a little hole there. If I was going to open this up and fill it up, that would be my volume. We okay with that? Like if I wanted to fill, like the Jell-O shapes, y'all ever seen like, little Jell-O molds you can make shapes? Those shapes that you're making, that's going to be the volume because it's all filled up. All right. Ooh, Jell-O shapes. I kind of want some Jell-O now. All right. Some other stuff that's important about volume. It says how you measure it right here. It says it's measured in cubic units, such as cubic centimeters. And the way that you write that, guys, is centimeters, but with a 3. Those centimeters with a 3. That's important. Or you could do like cubic inches, which would be inches with a 3. Guys, the way that I would read this is I would just say inches cubed. Or centimeters cubed. Now, when we were doing area, how do we read our measurement for area? Eli?
Whatever the number is, and then the measurement squared.
The measurement was squared. Let's think about that. A square. What shape is a square, Maggie?
It's flat, two-dimensional.
It's flat, like area. What shape is a cube? Three-dimensional, like volume. So those measurements match my formula. The measurements match what we're talking about. I couldn't get the special word out, okay? Volume of the figure to the right can be shown using cubes, which is why it's called cubic, or why we say cube, because you have to have an entire cube in there, not just a flat square. All right. I'll just move down right here where it says a rectangular prism. All right. So I'm not really worried about this sentence where it says it's a solid figure of two parallel and congruent sides and bases that are rectangles. We saw a rectangular prism yesterday. We learned what it looks like, how to picture it, all that, okay? What I care about right here is where it says to find the volume. To find the volume of a rectangular prism, you multiply the area of the base and the height, or find the product of the length L, the width W, and the height H. So do you see how it gives me two different ways to work it? It says I can multiply the area of the base and the height, or I can do the length times the width times the height. All right, you'll see right down here I've underlined this V equals LWH. That's what we learn in the 6th grade. All right, which is fine and dandy because y'all are in the 6th grade, right? But at the end of the day, is 6th grade where you stop? No. So I want to talk about this other measurement. Do you see where it says big B times H? This big B is where it says the area of the base. So does big B just stand for base? No. Big B stands for the area of the base. So when we were talking about area, some of y'all wanted to use big B. And I was like, no, don't do that. Because like on area equals base times height, that little b just means the length of the base. Does it mean the area of it? No, that's what we're trying to find. But now that big B does mean the area. So I want you to look at this big B for just a second, okay? So I have a big B here. Y'all with me? Big B stands for, remind me again? Area of the base. All right. If I'm talking about a rectangular prism, what shape is my base? If it's a rectangular prism, what shape is my base? Hayden? A rectangle. Are we good with that? Okay, so big B, if it's a rectangle, what is the area of the base of a rectangular prism? What is the formula for that? How would I find the area of a rectangle? You got the sheet, Hayden? You got the sheet? Okay, I'll post the video tonight, okay? I hope you feel better. Big B, y'all good with that? What is the formula for the area of a rectangle? Eli?
A equals BH.
Like the old one, the one that only works for a rectangle. What is the formula that only works for a rectangle? Length times width. Okay, so I want you to watch this. For a rectangular prism, my area of a rectangle is length times width, right? Do y'all agree? Length times width? And then it says to multiply by the height. Do y'all see that? So where do I get LWH? The LW comes from my big B. Okay? Now guys, I know that right now you're like, Miss, can I just use LWH? Absolutely, because we're in the 6th grade. That's what we're going to use. But next year, in the 7th grade, y'all are going to get to look at this shape. Is this shape a rectangular prism? No. This is a triangular prism. Guess what? This formula won't work anymore. But this one will. For this formula where it says big BH, right, if it's a triangular prism, what is my big B gonna be? Maggie?
It's going to be whatever the base of the triangular prism is, with the number.
All right, remember, big B doesn't stand for the base of something. It doesn't mean that measurement. Think about what big B stands for. Remember, the area of the base. So how would I find the volume of that triangular prism? Hayden?
So at the bottom triangle, you would get the area of that, and then you multiply that by the height of the triangle.
Perfect. So I would need to know the area of this triangle, correct? And that would be my big B. Do y'all agree with that? The area of this triangle would be big B. So that's base times height divided by 2, right? So I'd do base times height divided by 2. You could do it for the top one or the bottom one because they're the same, okay? So I'm going to do the area, which would be the base, times the height divided by 2. Then I have to multiply it times the height. Am I talking about the height of this triangle anymore, though? No, I'm talking about how tall is this prism. So it's still the same thing as LWH, but instead of having LW, is this area LW? No, it's base times height divided by 2, and then I multiply it times the height of that. Okay, this is where you're going. All right? Miss Donahue came in last period, and I blew her mind because I asked my second period how to find the area of this triangular prism. And they were able to tell me because we had the same exact discussion. All right? And she thought that I had the smartest students in the world because this is not 6th grade. This is 7th grade, and y'all are able to figure that out now. Here's the thing, guys. What if instead of having a triangular prism, oh, I'm going to really throw you for a loop now. What if I had this shape? What would this be considered? Any guesses? Braden? Prism. It's a trapezoid prism. It's a trapezoidal. I guess that's how you say that. Okay, prism. It's a prism in the shape of trapezoid. Guess what? You can find this area. You can find this volume. Raise your hand if you can tell me, how would I find the volume of that crazy shape right there? Juliana?
B1 plus B2 times height divided by 2 times the height of the whole thing.
So she's saying she's going to find the area here. She's going to do her B1 plus B2 times the height divided by 2 and find that shape. Because that's the trapezoid. Is it laying on that? No, but I know that's the base because it's in the shape of that, right? So I'm going to find the area. And then she said, okay, once I find that area, I can just multiply it times the height of that prism. Is my height going up and down? No. It's going side to side. Is that okay? Am I going from one trapezoid to the other? Yes. All right. Excellent, excellent job. Okay? Wrong screen. So with that said, the way I'm going to ask you to set up your work today, I'm giving you an extra step that some of the other math classes might not have to do. That's okay. Next year they'll be a little bit behind. All right? Or better yet, next year you will be a little bit ahead because you just saw where you're going with this. Okay? The other classes aren't necessarily doing that. Okay, so let's talk about how to set these up. They are super simple, and because they're super simple, if we add that step in now and you get used to it, next year, volume's not going to be a problem, all right? So, I want you to look at this first example. Do you see how they wrote the formula? Formula, length times width times height. Good. Then they said, okay, my length and width are 5 and 6. Okay, so this is where I'm going to give you an extra step. So here's their shape. Do y'all see where I have the line that says 5? And my line that says 6. Y'all see that? Which rectangle is that attached to? Hayden? The top one? 5 and 6, are they on the top? All right, they're not both over here. The 5 and the 6, what rectangle are they attached to, Stone? Right, but which rectangle are they attached to, Savannah? The bottom rectangle. Do y'all see how if I go around that, that's going to make that rectangle on the bottom? Is that better? Do y'all see that a little better now? All right? Or even better yet, I can just color in that whole bottom rectangle. Do y'all see how 5 and 6 are the bottom rectangle? Are we okay with that? So they used the length and width, and that's what they're calling their base. And then they said 8 is their height because it's going up and down connecting my bases. Are we okay with that? All right, so what I'm going to add in for y'all is you're going to have to color the shape that gives you your length and width. All right? And then they multiplied. They said 5 times 6 times 8. We can use our calculator for that. We get 240. 240 what? What should I put next to that? Braden? Inches cubed. All right? That's what your work should look like, and you should see that in your shape. All right, Maggie? Okay, so that's something you need to come see me in the morning about, okay? So come see me tomorrow morning when you get here, and we'll look at it. All right? All right, number 1. Number 1, we're going to do volume equals length times width times height, because that's my formula, right? So we wrote our formula. Now we need to pick our length and width. This is where I'm going to use that other color, or you can shade it in with your pencil. That's fine. What numbers am I going to use for my length and my width? What numbers am I going to use basically for the base? Remember, length times width is my base. Julia?
3 and 7.
All right, so 3 and 7. Is that going to be on the bottom? It's going to be in the front. So Julia says she wants to use 3 and 7. So she's using 3 and 7. Do we see that? All right, which is actually, do y'all see how that is the rectangle in the front of this entire shape? All right, so y'all agree with that? Okay, so I'm going to color that in. Hayden, did you use a different one? You can use a 3 and 4. And in fact, so Hayden said he wanted to use 3 and 4, and excuse the bad coloring here. But here's my last class, we used 3 and 4, so then my base was actually on the side. Are we okay with that? Does your base have to be on the bottom? No, think about that trapezoid. It just means it's been kind of tumped over on its side. All right? So I'm going to stick with what Julia said, so I'm going to use my length and width. So V equals, since I highlighted the 7 and the 3, I have to use the 7 and the 3, so 7 times 3, or you can do 3 times 7, doesn't matter. All right, but in this case, since I highlighted that color, could I have used the 4 for my length or my width? Since I highlighted that box? No. Hayden, if you highlighted the 3 and the 4, what's going to be your height? If you highlighted the 3 and the 4, what's going to be your height?
The height's going to be
3. Right. I use the 7 and the 3 for my length and width. What is going to be my height right now, Malachi? 4, because that's the one connecting the front to the back. For yours, you use the 3 and 4, so you use the side. What number is connecting your two sides? The 7, so that would be your height there, okay? All right? So when I multiply those, what do I get as an answer here? Mason, what do I get as an answer on number 1? All right, we're still on number 1. You're on number 2. All right, make sure you're paying attention. You look like you were drifting on me there for a second, okay?
Yeah, I'm right there, so.
Okay. You're writing on number 2 though, Mason, okay? Bailey? 84 meters, not squared. Remember, a square is flat. What number are you using? What number are you going to write for volume? Am I going to write a 2? Look at the example that was up above. A 3. And what that 3 means is cubed. All right? And Mason, make sure you're writing this on number 1. It looked like you were on number 2 a minute ago, okay? All right. All right, so we have 84 meters cubed. Malachi?
Is there a certain way you can multiply all that?
You have to multiply it in a certain way. But I can't tell you how every single person is going to do it because here's my work from my last one. All right? Cover that up for some of my people that want to copy, all right? So do you see how in my last class, did we highlight the bottom box? No, we highlighted the side. So what numbers go with my side, Malachi? 3 and 4. So I did 3 times 4 as my length and my width. And then I multiplied by 7 as my height. So you'll notice, are my numbers in the same order here, Malachi? No. But here's the thing. These numbers are correct because of what I colored. These numbers are correct because of what I colored. So the numbers have to be in order based on what you color. Does that make sense? All right. Now, as far as the length and width go, if you swap them up, that's not a big deal. Okay. So like here, if you did 3 and then 7 and then 4, that's fine. Okay. All right. So Malachi, in fact, I want to get you to help me with number 2. All right, so I'm going to write my formula first. Volume equals length times width times height. Guys, make sure that L is a loop-de-loop, okay? All right, Malachi, on number 2, what numbers are going to be our base? What numbers are going to be our length and our width here? 10 and 7. Because those two create the bottom. Do y'all agree with that? 10 and 7. Do those make a square, 10 and 7? Or a rectangle? Yes. So I'm going to color in that bottom since that's the shape that I'm using. Are y'all okay with that? Okay. Now I'm going to do volume equals 10 times 7. So Malachi, if you did 7 times 10, is that okay? Yeah. But what does my height have to be for this shape? 9. So the last number has to be 9. Guys, did I have to do the bottom as my base? No. Does anyone see another shape that it gave me? Anyone see any other shape it gave me, Juliana?
You could have also done the front or the side.
I could have done the front because it gives me the 9 and the 10. Which side does it give me? I don't know if it gives me a side. Which side would it give me? The left would give me the 9, but is there a line on the bottom of that? Does it give me that number, though? No. So you can use the front or you can use the bottom. Okay, we would just use those two. All right, so my volume equals, all right, what numbers am I going to multiply here? Eli?
You're going to multiply 10 times 7.
Oh, that was silly. What was my answer? I'm sorry. We already wrote that out.
630 centimeters.
Perfect. 630 centimeters cubed. All right, Bailey, I saw your hand a minute ago. I know it's not the problem that you wanted to answer, but I'm going to still call on you, okay? Number 3, for volume equals length times width times height. What would be a good length and width for number 3?
2.7 feet.
And 3. Very good. So where is my base going to be on this shape? What rectangle is it going to be? Now, what rectangle is going to be my base here? The bottom, the top, the side? The bottom is my base. Do y'all agree with that? The 2 and the 3 are attached to the bottom. Are we okay with that? So my length and width are the 2 and the 2.7 and the 3. Okay. What is my height going to be? 2 feet. Perfect. Guys, here's the thing. With your length and your width, they have to make a rectangle. If they do not make a rectangle, can they be your length and width? No. All right, so volume equals, when you work that out, what do I get as my answer here? What am I going to get my answer on number 3? Julia? 16.2 feet cubed. Very good. All right. So, guys, in a minute, you're going to flip that over to do your homework. Your homework is on the back. I want you to shade your base. Remember, write your formula, shade your base, write your numbers, write your answer. So you got 4 different things you're doing. Coloring, formula, numbers, answer. Does your base always have to be on the bottom? No. In fact, on number 1, there was no way it could be on the bottom. All right, I think on your homework, it could work on the bottom pretty much all the time. But double check. Make sure you're coloring in the right area, okay? All right, I'm going to turn this off. You're flipping this over and getting started on the back.